This is for Algebra 2. We're looking at polynomial functions, and what we're going to talk about today are the degree of a function and the end behavior. So to start with, the degree of a polynomial in one variable is the greatest exponent of its variable. The leading coefficient is the coefficient of the term with the highest degree. So you look through, it doesn't matter what order they give it to you in, as long as there's only one letter showing up. The degree is the biggest exponent that you ever see. So on this one, your biggest exponent is right there. So for this problem, your degree is 4. The leading coefficient goes back to the term where the degree came from, and it's just whatever the coefficient was. Now you got to be careful and watch and make sure you get the sign. So on this one, your leading coefficient is -2, and you're done. So looking down here, state the degree and the leading coefficient of each polynomial. If it is not a polynomial in one variable, explain why. So we only have one variable, so it will work. So I'm going to find my degree and my leading coefficient. My degree is going to be the largest exponent that I ever have, so my degree is 4. The leading coefficient will be the number in front of that term, and so it will be 3. Number 2, your degree is going to be 7. And your leading coefficient is going to be 10. Number 3, your degree is going to be 8. Your leading coefficient is also 8. This is the term I used for this one. This is the term I used for this one. Number 4, your degree, and you start looking and you notice, oh look, it has 2 variables. So there is no degree or leading coefficient because there are 2 variables. Number 5, your degree, you're going to be looking at this one, is 5, and your leading coefficient is -9. Number 6, don't let the fraction confuse you. Still just go look at your degrees or your exponents. So your degree is 6, and then this is where you got to use the fraction. That right there is the same thing as saying -1/25. X over 25 is like 1/25 x. So that's all there is to that part. Really simple, and so you have to wonder why we're doing it. Well, we're doing it because you need to be able to do that in order to do the next part. To determine the end behavior of if the degree is even and the leading coefficient is positive, then, and they've written it pretty confusing here, as x approaches -infinity, in other words, at the left side of your graph, it's going to be positive. And as x approaches positive infinity, which means the right side of the graph, then it's also positive. So basically, if it's even and the leading coefficient is positive, the end behavior for both ends will be positive. If it is even and the leading coefficient is negative, it's going to be negative for both ends. If the degree is odd and the leading coefficient is positive, then the left side will be negative and the right side will be positive. If the degree is odd and the leading coefficient is negative, then the left side is positive and the right side is negative. So kind of a summary of that. If your degree is even, they're going to be the same on both ends. If it is odd, they're going to be different. Okay? Meaning that an example of same on both ends is if you had something like this. See how it's going up here and it's going up here? They're the same. An example of odd, meaning it was going to go different, would be something like this. It's going up on the left and it's going down on the right. Okay? So that's just kind of an example of what we're even talking about. Now, what you need to also keep in fact, though, is that if it's positive, then they're both positive. If it's negative, they're both negative. If it's different and it's positive, it's going to be negative and then positive, which would be down and then up. And negative would make it positive and then negative, or up and then down. So you could either summarize this. If they're going to be the same, they're either both positive or they're both negative. Okay? So this would be if you had a positive or a negative. If they're different, if you have a positive leading coefficient, then you're going to be minus and then plus. If you have a negative leading coefficient, you're going to be plus and then minus. One more thing you need to be aware of, you might want to write down, a real zero, okay? This is talking about where it crosses the x-axis. A real zero is where it crosses the x-axis. Okay, so just write that down because you're going to use that later too. All right, so maybe it'll make more sense when we actually look at some problems. So let's go to the next page. All right, looking at the top at the first example, determine whether the graph represents an odd degree polynomial or an even degree polynomial, and then state the number of real zeros. Okay, notice it's going down here and it's going up here. So they're going different directions, right? So since it goes different directions, this means that it must be an odd degree. How many times does it cross the x-axis? It crosses the x-axis once. So the number of real zeros is 1. 1 RZ, real zero. And that's all it wants. So determine whether each one is an odd or even and the number of real zeros. So looking at number 1, it goes up. It also goes up. That's the same direction. That means that it is an even degree. And we have 1, 2, 3, 4, 5, 6 real zeros. They go down, so that means it's an even degree because it's the same direction. It gets up here and touches it once, and so you have 1 real zero. It goes up, and then it goes down. That's opposite directions. That tells me that it is an odd degree. I have 1, 2, 3 real zeros. Crosses the x-axis 3 times. So that's pretty simple when they just give you a graph. If they give you an equation, you're going to want to look at your degree, okay? What is your degree? It's 3, so that tells you that it's odd. Okay, look at your degree on this next one. Highest level or highest exponent is 3, so it is also odd. Down here we have another odd one. And we finally have an even one. Okay, I'm looking at your biggest exponent. If it's an odd number, it's an odd degree. Even number, it's an even degree. Okay. My suggestion to figure out the number of real zeros is to take it and put it into y equal and then look at your graph. So if we have x to the third minus 4x squared plus 7, I'm going to go zoom 6 and just look at my graph. How many times does it cross the x-axis? 1, 2, 3. So I have 3 real zeros. So then I'm going to go back to y equal, clear it out, and this time we're going to have x to the third minus 9x squared plus 24x minus 15. I'll look at my graph. 1. Oh, how many times does it cross it? It nearly gets there, but it doesn't quite get there. So you only have 1 real zero. So on this one, 1 RZ. So then I'm going to go back to my calculator, go to y equal, clear it out, put the next one in, and we have x to the 5th minus 4x to the 3rd plus 5x plus 2. Look at your graph. 1, 2, this is going to be kind of hard to see. So I'm going to recommend that we zoom in. Number 2, enter. 1, 2, 3. Looks like we have 3 real zeros. So I'm going to come over here. 3 real zeros. Last one. Back to y equal. Clear it out. 2x squared plus 12x plus 12. Look at your graph, and we may be zoomed in too much. Let's go back and go zoom 6. And it looks like you have 2 real zeros. I recommend that you always start at zoom 6, kind of a standard screen. Okay, so that's the end of the notes. You have a worksheet. If you have any questions, call me over.